Today we're going to talk about sensation and perception and how when we take in information with our eyes, our brain has to make sense of it. I'll talk a little bit about hearing. The visual illusions are a little bit easier to show you, but the same thing does happen with our other senses. Our brains have to make sense of the information that's coming in. So I'm going to ask what you see here. Now, most of you would say a light bulb, and the reason you say light bulb is because you know what this is. You know the word for it. You know what it does. So you're bringing your prior knowledge and experience in here, right? Now, if I ask you to describe what you see and actually describe what you see rather than interpret what you see, you are going to use words like round, shiny, black and white, etc. And even then, we're using our prior knowledge, right? You know what shiny is. You know what reflection is. And that's why you're describing what you're describing, right? So what do we see here? Now, if you are, the most of you will see, the first thing you will see is shiny legs. And then as your eyes get a chance to adjust, you may see legs that have paint on them, white paint, right? Okay, so most of you had your brains primed by the shiny light bulb, and then when you saw this, you saw shiny, okay? Doesn't work for everybody, but it's just an example of your expectations affecting what you see. So again, our perceptions filter our experiences of the world through an imperfect personal lens, right? So your personal lens in that moment was primed for shiny, and you saw shiny. It matched, the white matches what you expected, right? But then when you don't expect the shiny anymore and you expect paint, you see paint, okay? Here's an example of what we call bottom-up processing or top-down. So we're going to start with bottom-up. Bottom-up means you look at the parts. So if you look at these blue lines here, what you'll see is blue lines, and you try to make sense of those blue lines, that's bottom-up. So you're looking at the parts, and then you are trying to make sense of them, okay? More typically, what we use is called top-down processing, which is what happened with the light bulb. You weren't looking at the parts to decide what it was. It was more of a whole thing. You used all your prior knowledge and experience to decide what that was. And then you confirmed it by looking more closely. Okay. So now you would probably see a B here. A, B, C, same shape as before. But in top-down processing, you're going to use the context clues of the A and the C, and you're going to see a B. Okay? Sorry, same picture. So now with this one, you're going to see a 13 most likely, right? 12, 13, 14. So again, top-down processing, using your prior knowledge of numbers and the context cues that are going to tell you what that is. Okay? And then let's look at another cue, context cue that our visual senses and use to perceive and understand what we're seeing. And here we're talking about depth cues. So how far away is something or how deep is something. Those lines are depth cues, and they make the top figure look larger than the bottom figure, even though they're exactly the same size. Okay. So with figure ground, this is another one, figure ground illusion, where often you will see, you might see a face where the black is hair, and this is an eye, and it's a white face. Or you might see a sax player, a silhouette in the black of a sax player. Whichever one you saw first doesn't mean anything other than you saw that one first. Something about your prior experiences led you to believe that, possibly, right? But then most people can eventually see both. And you're using cues there to see those things. Typically, we're just looking for ways to differentiate between the figure and the ground, and figuring out where, how an image is working based on those kinds of cues. Without those cues, like here, we don't really have a lot of cues. We start to see different things, right? Whereas in here, there's a lot of cues to see those things. So now just for some auditory situations, let's just watch this.
Before we go inside this busy bar, can you understand these garbled words?
This sentence, does it sound strange?
The words are hard to make out, and if we head inside, with music and people talking and coughing, it should be even harder to hear them, right? Well, let's take another listen.
This sentence, does it sound strange?
Amazingly, it's not so hard to hear those words now, and the sentence doesn't sound so strange at all. This is called the phonemic restoration effect. Your brain anticipates a fluid, complete sentence and fills in this missing phonemic sound. Pretty amazing, huh?
Okay, so there's another video on Blackboard that describes this a little bit more fully, but your brain fills in missing parts, just like with sound. Just like with vision. And then there is the McGurk effect. I'll just let the video tell you what it is.
At any one moment, we are being bombarded by sensory information. Our brains do a remarkable job of making sense of it all. It seems easy enough to separate the sounds we hear from the sights we see. But there is one illusion that reveals this isn't always the case.
Ba, ba, ba.
Have a look at this.
Ba,
What do you hear?
ba, ba, ba. Ba, ba, ba.
But look what happens when we change the picture.
Ba, ba, ba. Ba, ba, ba. Ba.
And yet, the sound hasn't changed. In every clip, you are only ever hearing bar with a B.
Ba, ba, ba.
It's an illusion known as the McGurk effect.
Ba,
Take another look.
ba.
Concentrate first on the right of the screen.
Ba,
Now to the left of the screen.
ba.
The illusion occurs because what you are seeing clashes with what you are hearing.
Ba.
In the illusion, what we see overrides what we hear. So the mouth movements we see as we look at a face can actually influence what we believe we're hearing. If we close our eyes, we actually hear the sound as it is. If we open our eyes, we actually see.
So sorry.
Might override or at least combine. It has the conflicting information to try. Ba, ba, ba. Conflicting information. It tries to make sense of that conflict. And depending on what type of modality is providing more, salient information, that information might override or at least combine with the other information.
So we can't always trust what we hear, because sometimes our sense of vision takes over, enabling us to maintain a coherent view of the world.
Okay, sorry for that mistake. This will be in Blackboard as well if you want to watch it again. So just to wrap up, our brains make sense of the world, right? Our senses take things in, and perception is making sense of it, right? I just have this slide here just to remind you of some of the things from our cognitive unit where we talked a little bit about inattentional blindness and change blindness. So inattentional blindness is when things are happening around us and we're not paying attention to them, so we don't see them, right? And how our brain, purposely filters things out, because otherwise it would be difficult to focus on anything, right? And then with change blindness, things change in front of us. So if you watch the whodunit video, Illusion, then that is the one that it illustrates change blindness. So things change right in front of you and you don't see them. And that is, and illustrates things like driving and how you don't always notice things in front of you, a person walking or a cyclist, etc., even though things around you are changing. So our brains can play tricks on us, certainly, right? And so that idea that, reality is what we see, or what we see is reality, is something to be questioned and challenged on a regular basis.